matrices. And I just started my video here, but we did a quick warm up that reviewed what you were supposed to do after the test on Thursday. It's a review of matrices. If you need to pause the video here, you can watch it and go back over and make a connection to each answer. What we're going to do is we're going to jump right into something that you've already seen before. Now, I want you to look at this. Don't write this. The reason why is it's a review. But these skills that we're practicing and reviewing, they are skills that you will need to have mastered when you get to calculus. So those of you that are thinking about a career in math or an education in math and science, you really need to kind of buckle down and make sure you're comfortable with these. So here's what we got. I'm going to solve the system by graphing. I'm going to do this very quick. You don't have to write, it's just a quick review. But what do I want to do? I want to solve the equations for y. We're going to get this in the forms of y equals mx plus b, right? Because I'm going to graph these and then we're going to find the solution. So I'll do this very quick. Here's my first equation. I've got a y-intercept of -3, and then I have a slope of up 1 over 1, 2, 3, 4. And that slope will continue on up 1 over 1, 2, 3, 4, for as far as I can draw it. Now, I have the luxury of using a smartboard, and there's my graph for that piece. The second one is solving for y again. I'll divide by 5. And 2/5 here. I go up 2/5. Now 2/5 is right about here. It's not perfect. And then I have to go down 3, so that's 1, 2, 3 over 5. 1, 2, 3, 4, 5. Now this is a very rough sketch. If I was going to do this a little better, I would have more. Fix that. I would have a better system. But what do we get? Anytime we graph two equations, if they cross at a point. Now, this might not be perfect. This might not be the best possible location. I'm going to estimate because I'm not 100%, but I can kind of guess what's my solution. Over 1, 2, 3, 4, down 2. So the location where they intersect is over 4, down 2. And that is right now the guess or estimation of my solution. Okay? So that's solving systems by graphing. We've done that for quite a while. I would like you to write this one down. We're going to take that exact same problem, but we're going to do this by substitution. And the reason why I want to write this one down is this is a skill that you must master when it gets to calculus. I've done this skill in my calculus class about 3 times in the last week, and I have some students that still struggle with it. So I have the steps here, and we're going to kind of walk you through just to make sure you're comfortable with this. But I'll give you a second to write this down. Take the same system of equation. There's 2 variables, 2 equations, and 2 unknowns. We have 2 x's and we have 2 y's. What are they equal to? Well, we have an idea of what the answer should be because I graphed them and it gave me a pretty close estimation. So now I want to solve one equation for x or for y, and it doesn't matter which one you pick. However, there's usually an easier choice. So I'm actually going to have you guys take the first equation. and we want to solve for x or for y, whatever one looks easier. In my case, or my guess, if I solve for x, that's going to be probably the best possible option because dividing both of these by 2 gives it a friendlier answer. So let's take the first equation and solve for x. Look at x by itself. And then when you're done, you should be able to plug x equals your answer into the other equation. So go ahead and try this. I want to see how much you remember. All right, let's take a look at this. So I want to solve for x, which means I'm going to move the y over to the other side. And then I'm going to divide everything by 2. Now notice, that doesn't give me an answer, right? It gives me what x is equal to. So now that I know what x is equal to, we're going to go to the other equation and plug in what x is equal to. So, yeah, okay, she left. Anyways, so take the other equation, and we're going to plug in exactly what x is equal to. Now notice, what are we doing? We're taking an equation that has both x's and y's, and we're substituting in something that has just a y, which means now I have all y's here. So we can now use any algebra we need to solve for that remaining y. Now it's just a lot of algebra. Distribute the 3. I'm going to combine the y values. And then at the same time, I'm going to subtract the 36 over. And if I divide by 17, I get y equals negative 2. So now we actually know what y is. And then you have an option. You could plug y back into any equation, but I always highlight this part. Don't we know what x is equal to? If I know what x is equal to, then I can go right back to what y is and plug y back in to find x. So then I get negative 8 plus 12 ends up being positive 4. And my solution is at the spot 4, negative 2. So we've done this in Algebra 1. We've done it in Algebra 2. We're doing it in pre-calculus, and you will be expected to master this in calculus. So hopefully you're really comfortable with that. All right, I got one last piece, and there's a reason why we're doing this, okay? Remember, this is a system. It's when you've got two, in this case, 2 equations and 2 unknowns. We don't know x and we don't know y, so we have different ways to find that. We could graph them, we could do substitution, or we could do elimination. Now, on this one, I don't want you to write this. The reason why is I actually very rarely use this method. I prefer substitution. And I'm just going to show you quick so you have a quick reminder of how this works. But don't write this yourself. All right, I need to multiply one or both items by a number so I can get them to add up and be eliminated. Well, the thing that I notice is that 2 and 3 don't have a common factor, 8 and 5 don't have a common factor. So I get to choose, and I want to multiply the top by whatever this term is. So this here I've got a 3, so I'm going to times this by a 3. And when I do that, everything is being multiplied by the 3. Let's see, that's 60, 72, I believe. And then down here, I want to multiply by a 2. But I want these to be opposite signs, so I'm going to make this one a negative 2. I could have multiplied by a negative 3. Either way, it would have been fine, but I'm going to distribute the negative 2 to all of these pieces. So I get a negative 6x, and then I get a negative 10y, and then I get a negative 4. Now notice, when you do that, you have one pair of variables. In this case, the x's are exactly the same, but they differ by a positive or a negative. Well, when we do that, now I'm going to add straight up and down, and that eliminates the x's. So what's left over then is 34y, negative 34y, equals negative, is that 68? Yeah, negative 68. And then we're just going to solve. We've got one variable left. And I get y equals 2. Well, then I pick any equation. It could be the multiplied one, it could be the original. I like to pick the easier one, so I'm going to pick the very first one, the top equation. Now we're going to plug y equals 2 right into there. And now it's just quick algebra. Go ahead and solve. So if I add 16 over to the other side, let's see. Yeah, sorry, I'm just double checking things in my head. I get 30, 40, I get x equals 10. That should have been the same. Did I make a mistake somewhere? Yeah, that still doesn't, thank you. That still doesn't work. It should, I'm going to go back here. Is this the exact same problem that I copied? I should have gotten the same answer. Three. Sorry, I'm just double checking my work here to see if I made a mistake somewhere. 72. Negative 34. Interesting. Yeah, I'm not quite sure why. I'm going to have to double check this one. We should have got the same answer we did before. I don't see it right now. Maybe I'm missing something, but that's the idea. I'll go back and double check that and see why it didn't work. But the question now is why? Why? We have three different ways we could solve systems. You could graph, you could do a substitution, or you could do elimination. Well, there's another one. Oh, this is just a quick reminder. Anytime you solve a system and you get a false statement like 0 equals 0, so if the variables cancel out, if the x's cancel out or the y's cancel out, you get 0 equals 2 or anything weird, well, that means that there is no possible solution here. 0 can't equal 2. 3 can't equal negative 1. 4 can't equal 7. So there are no solutions, which basically means if it's a linear system, you are graphing lines that are parallel. They're never going to cross. All right? But what if you end up with the variables canceling out and you have a true solution? What if 0 equals 0, 7 equals 7, negative 2 equals negative 2? This means that your first line, if you were to graph it, is actually the exact same thing as the second line. So when you end up with the true statement, remember that is what we call the infinite amount of solution. Every single x pairing on that line will create a true expression, which means will work. Okay, so that's the prerequisites we need going into this piece on matrices. So what I'm going to have you guys do is this. We're going to try something a little different this time. I'm going to put a link in the chat, and I want you to click on this, and it's a video that's going to start. Now, I think it starts at like the 6 minute mark, but if not, can you fast forward to